Ready? Okay, so as I was, well, let's do this first. Allow, Sitlali, Rachel, Melanie, Christina, Joel, Merciful, Val, Tanya, Franklin, Lucas, Matthew, Sankavia, Jaden is here, Annalise is here, Zane, Indira is here, Kamani is here. All right, so I've decided actually for this exam, I'm not going to make it cumulative still. This exam is only going to be on probability. The next exam that you're going to take, though, it's going to be kind of more like a midterm or something. That exam will be cumulative. Okay. So that one's going to be on the first 3 chapters or first the material associated with the first 3 exams. Again, also, the final exam will be in class. Okay. So please remember that you will need to have your calculator. You won't be able to even do the problems really in chapter 5 without the calculator. Chapter 6, it's impossible. All right. There's a bunch of you guys I see still don't have the calculator. So so please keep that in mind. Again, you can check them out from the ASC, the Academic Success Center. If you go there with enough time, they have extras there. Right now, I know they still have some because I know students were still requesting it. Also, like, don't forget, this thing is online here with this entire schedule for everything we're going to do. Okay. And that is just in the start here folder or whatever. Okay. And I guess that's about it with that. So let's finish this chapter. Okay, so now we're up to something a little different now. This is now about counting. And you're like, counting, I know how to count. Is kind of one of the worst parts in math, though, right? So like knowing how to do these counting questions, right? But for this class, we're not going to do too many of them. So there's only going to be a few types. So we only have to talk about those, okay? But you have to know that there's no other way to do these things. The way you would be to do these things would be to write out all the cases. And writing out all the cases might take a really long time, okay? So we're going to review a bunch of this counting stuff now just to make sure that people know how to do them. I'm going to try and do an example with each one, and then we'll go and do the problems, okay? All right, so counting. So the first thing that people usually talk about is this thing called factorial. Does anybody know what factorial means? Like if I say like n factorial like this? Multiply each number before and that number too. Okay. So like this equals to, whoops. Where did it go? This equals to, and we say n times n minus 1 times n minus 2 times lots more stuff times and then like 2 and then times 1. But effectively it's like, all right, so let's say you have 5 factorial. So if I just push equals here, it'll tell me it's 120. What does that mean? 5 times 4 times 3 times 2 times 1. Does that make sense? 4 factorial, that's equal to 24. This is 4 times 3 times 2 times 1. Does that make sense? All right. Does anybody know what 0 factorial is? Sorry? 1, why? Does anybody know? Does anybody know what any of these things mean? Oh, this thing's not giving me the answer, really. It's 1. What calculator won't do it for some reason. What does factorial mean? Does anybody know? Other than just like that's how you calculate it? Because I mean, it doesn't really matter if we don't really know what it means. Why I'm not going to know what to use it for. Does that make sense? Does anybody know what it means? N factorial is, or I'm going to write n factorial here, sorry. N factorial, what that means is the number of ways to arrange n distinct, or let's say distinguishable items, okay? Sometimes you could think like instead of it saying arrange, you could think it means the number of ways to like line up and distinguishable items or things, okay? So let's try and do an example with this so we can see if this makes any sense what I'm saying here. So let's say we have the letters A, B, C, D, and E, okay? So we have 5 letters. They're all distinguishable in this case. They're not like none of them, they're different from each other. Does that make sense? All right. So then if I said to you, how many 5-letter words, I put words in in quotes here because they're not really necessarily words, but letter combinations, I guess I should say. How many 5-letter combinations can you make using each letter only once? Do you understand what I'm saying? How many, if I use all of the letters, how many different like words how many different words could you make using each letter only once? In other words, I'd have to use all of them, but I want to use all of them and then I want to know how many I can make. Anybody know how you do this? If you were gonna make, you have an idea? Sorry? Why? Just because I'm saying factorial doesn't mean that's necessarily the answer. But the thing is like if you don't understand what it means, doesn't matter. You're not gonna be able to use it. If you started trying to make a word, right? What would you try to do first? Probably pick the first letter. Does that make sense? Does that make sense? So what I always do is I try to write something sort of like this, where I start referring to these things as slots. Does that make sense? Or sometimes people call them boxes or whatever. All right. Something has to like go in here, something has to go in here, something has to go in here, something has to go in there. Does that make sense? How many choices would you have for the first one? How many choices would you have for the next one? 4. So what if I had to make just 2-letter words? How many ways would there be to do that? If there's 5 choices for the first one and 4 choices for the second one. No, if I was just gonna make, if I changed the question slightly, and I said like instead, how many 2-letter words can you make using each letter only once? What would your answer be? Way more than that. You have A, B, C, D, E. I could do like A, B, A, C, A, D, A, E. I could do E, A, E, B, whatever, all that stuff, right? So how many would there be? And if you know how to multiply, you should be able to do this. So we just said that there's 5 choices for this one and then 4 for that one. Is that correct? Yeah, right. And the reason why I'm saying is, if you know how to multiply, you should be able to do this because this is honestly, when I was in school, it's a lot of what they were doing was this is how they taught me how to multiply. Does that make sense? So so my point is I know you can do it. All right. So we said there's 5 choices for this one, right? So what are those 5 choices? A, B, C, D, E, right? So for the first letter, could be what? A, B, C, D, or E. Is that correct? How many choices do you have for the next one? What would they be? Second? Depends on which letter, of course. Does that make sense? Because if you picked A for the first one, I can't have A again, right? Because we said we can only use it once. Is that correct? So if I had A, what choices do I have for the second letter? B, but B, no, not depending. You can have a B, right? Because if the first one's an A, second one could be either what could the second one be? Could be B, could be C, could be D, could be E. Is that correct? Right? This could be B, C, D, or E. Is that right? Does that make sense, guys? And then for the next one, it would be what? A, C, D, E, whatever. And then this would be A, B, C, D. Is that correct? Does that make sense? Question? Silali, question? All right, so then, all right, so how many words could you make here then? How many 2-letter words could you make starting with an A? 4. There's 4 here. Is that correct? How many could you make starting with a B? 4. 4, 4, 4. Does that make sense what I'm saying? So how many should we have total? 20. But you should be telling me that you know how to multiply. You should be telling me that when you have 5 choices for the first one, right? For each one of those choices, there's 4 choices for the second one. Is that correct? So it's 5 sets of 4. Is that right? Does that make sense, guys? Does that make sense? All right. So I'm just writing these slots, but you should be telling me that this would then be 20. Is that correct? Does that make sense, guys? Does that make sense? And I mean, you could just write them all out. I mean, I just really almost just wrote all of them out. Is that right? Now, for some other ones, though, you're not going to run and write them out because it might be too big. Does that make sense? So you're going to have to know how to count them. Question? But I'm telling you, this is not something you can do without doing practice. Does everybody understand what I'm saying? Does everybody understand? And it's going to be on all of your exams once we take the 3rd exam from then on. Does everybody understand? All right. You have to know how to do these things. Okay. Otherwise, also, the other things won't make any sense to you. Does that make sense? All right. So 5-letter words. Let's go back to this because we didn't finish this and I just started babbling. So then here, if this is 5 and this is 4, well, then I think it should be clear that the next thing would be 3 because then we would only have 3 things left because we already picked 2 of them. Is that correct? Then there would be what? 2 and then 1. And then this is equal to 5 factorial, which gives you 120 different ways or 120 words we could make. Does that make sense? The problem is that like I don't think this makes sense to anybody. I think this makes sense to everybody though. Does that make sense? You understand what I mean? It's not about knowing these formulas. It's about knowing what they mean. Otherwise, you can't use them. Okay. And the problem is you're not going to know based off the question which one to use necessarily. All right. So you're gonna have to. That's what we need to pay attention to. Does that make sense? What I'm saying. All right. When to use each one, and then every single time it's the same thing. Does that make sense? All right. Question here so far? Anybody? Hello. Anybody? Is it okay? All right. So, like, believe it or not, this one I just did. Okay. What just happened? This one that I just did right here, like, you kind of can't do this with factorial, sort of. Or if you were going to do this with factorial, I would have to start saying that this is going to be like 5 factorial divided by 3 factorial. Because this is like 5 times 4 times 3 times 2 times 1. And then 3 factorial is 3 times 2 times 1. And if we did this, these things would cancel. And we would get the same answer, 5 times 4. Does that make sense? But that's kind of stupid if you think about it. Like, why would I do all of that when I don't have to? Does that make sense? Does that make sense? Now, we need to talk about this a little bit to explain what we're going to do for some of the rest of this stuff. But believe it or not, like this example that I just showed you here is really going to be the same thing as what I'm about to explain. All right. So they talk about these things, permutations. Does anybody know what the word permutation means in English? Because this is part of I think the issue that a lot of people have with math a lot of times is that they'll use these words that we don't use that often in English. And then all of a sudden people are like, I don't know what it means. Well, of course you don't know what it means. I don't even know what they're talking about in regular English, let alone with all these numbers and stuff. Does that make sense? Does anybody know what this stupid word means? Does anybody, well, maybe not permutation, but does anybody know what the word permute means? Like English people use this word for some reason, not Americans. All right? Yeah. So permutations is really just another word for arrangements. Right? So in other words, a permutation is an arrangement of something. To permute something is to rearrange it. All right? So they write this symbol NPR like this. This is the number of permutations taken R at a time from N distinguishable objects. Or in hopefully a little better English, I don't know, that's the way everybody says it in every book. Does that make sense? Does that make sense? All right. But the way I like to say it is the number, I mean, permutation just means arrangements. So why don't we just use the word arrangement? The number of arrangements of R many things taken from N distinguishable things. All right. So believe it or not, on this previous question here, the one we just did, in this case, N is really 5. And then R is 2. Because you're arranging, you want to arrange 2 things out of the 5. Is that correct? Does that make sense? Does that make sense? Now, like, again, I don't really like do it this way that the book is saying to do it because I think it's kind of stupid. But I think you're supposed to just ask yourself how many ways you can do it each time. So you should be saying to yourself, there's 2 letters here. How many ways can you select something for the first letter, right? So that's 5. Does that make sense? And then it's 4. And the answer is 20. Okay? Right? Now they're going to give us a formula for this, which you can use if you want. I don't really recommend it. Otherwise, you're not going to understand, really. All right? But the formula is, well, does anybody know what the formula is? N factorial divided by n minus r factorial. That's the formula. Okay? Yeah. Uh, this. Like when you have 5, you do 5 times 4 times 3 times 2 times 1. When you have 4, you do 4 times 3 times 2 times 1. So then we're going to use that in this case and see how the formula applies in this case. Okay. And then I'm also going to explain why the formula makes sense. So, but again, the only reason why I'm explaining why the formula makes sense really is to explain the next one and to make sure we understand what we're counting here and how this all works. Does that make sense? All right. We're going to need to understand this for the next formula. As you see, I didn't need to use the formula to do the question whatsoever. Does everybody see that? All we did was write out the slots. That's the way I recommend to do these. Does that make sense? All right. But to understand the next one, we got to do this. All right. So what is this? So NPR. All right. So you just plug in the numbers here. So this is 5P2. Does that make sense? N is 5, R is 2. Is that right? Then this is 5 factorial over 5 minus 2, right? That's 5. That's 5 minus 2. Does that make sense? Then what would you do? What would you do next here? Right, but well, first I gotta do 5 minus 2. Is that correct? You always do is in the parentheses first. Is that right? So then this is 5 factorial over what? 3 factorial. Then you should write them out. And then cancel out whatever's common factors. Does that make sense? Does that make sense? Now the only thing is you really shouldn't write out the whole thing. Where should you stop? Sorry? Say it one time? If I have 5 factorial over 3 factorial, where should I stop writing it out on the top? At 3 factorial. Because this is always going to end with something here. Then there's a 3 factorial on the bottom, and we could just cancel those. We don't need to write them out. Does that make sense? Doesn't really matter, but I'm just saying. Does everybody understand what I'm saying? Question with that? Everybody okay so far? All right. So that's that formula. Does everybody see that? Let's do some other example. Okay. So let's say, oh wait, I said I have to explain the formula also. We'll do one more example, then we'll explain the formula. Okay. So, how many ways can you visit 5 cities out of 8 on a trip? Does that make sense what I'm saying? So there's 8 cities. I just want to know how many ways can I visit 5 of them. Does that make sense? You get what I mean by a way to visit them? No. No. Sorry? The order you end up going them in. Does that make sense? But you could ask the same question, all right? how many ways can you listen to 5 songs out of 8 on a road trip? Does that make sense? But how many ways they're asking? How many ways could they be shuffled? Okay. How many arrangements? All right. And then they're saying like another one would be how many um ways could you schedule 5 classes out of 8 different classes in a day or something? Does that make sense? They're all the same question. Does that understand what I'm saying? They're all the exact same answer. How do I do any of them? I just said we don't really ever need to use the formula. And if you use the formula, you probably don't understand. Yeah, but I just said I don't really want to use a formula. Like, there's no reason to use a formula. So what did I say to do? We've only said to do one thing. Sorry? One more time? 5 times? No. No. Close, but no. Yeah, I want you to write out the slots. Does that make sense what I'm saying? Why would you write out 5 slots? Because there's going to have to be 5 cities that we have to go to or something. So then, or 5 songs, or 5 classes that they needed to pick. So this represents the first city we went to, etc. Is that right? All right, then what? You have 8 choices for the first one. Is that correct? Then you have 7, then you have 6, then you have 5, then you have 4, unless we were able to go to the same places twice. Does that make sense? Now, what if you were allowed to go to the same places twice? What would the answer be then? What if you could go to um, cities multiple times? Or in other words, like it kind of makes more sense with the songs or whatever. All right. Let's say we were going on a road trip. We got these songs. There's 8 songs or something like that, and then we're gonna sit there and we're gonna start playing those songs, whatever they are. Okay. We're only gonna get a chance to play 5 of them, because that's how long the car ride takes. Does that make sense? But then, like like he's annoying. He's like he likes to listen to the same song over and over and over again. And then you're like, I don't like listening to the same song over and over and over again. I'm like, wait a second, we gotta at least let him listen to it twice, right? But then we got, I don't know. I just want to see how many times, what would happen, how many different ways we can listen to songs if we could listen to them more than once. Does that make sense? Or just once, or not at all. Does that make sense? And that's this question now. How would you answer this question? If you think about it with my slot stuff, it's easy. If you think about it with this other garbage, you'll never get it right. Yeah. So all you do is write these slots here, same exact way we were doing the previous question, because there's still going to be 5 that we're going to pick. Is that correct? But now the difference is how many can we select for the first one? Well, that doesn't really change. There's still 8 choices. It's the second one that changes a little bit. We would be able to select 8 for that one as well. There'd be 8 choices for all of these. So therefore, we'll get that answer. Does that make sense? Does that make sense? Melanie, question? Does it make sense, guys? Yes? No? How many choices you got for the first song? 8. How many choices you got for the next one? But you did miss the beginning, so that's why. Okay. Any question with this so far? Does everybody understand what I mean by permutation? All right, there's something else that people always say when they say permutations, and the only reason why they say this stuff is so we can compare this to the next one, because this is how you end up deciding what to do. All right, this is the most important part now. All right, so order matters. Okay, when you're doing an arrangement, the order in the arrangement makes a difference. Like AB is different than BA. Does that make sense? Does that make sense? All right. Now, I said I was going to explain this formula a little bit because it can help us to explain the next one, sort of. All right. So what we just had there, like whatever, we can use this one. How many ways are there to visit all 8 cities? What if you're going to all of them now? How many ways would there be to visit every single one of them? From you. Yeah, this you said this the correct. Way more than that. 8 cities. You know that when they run the World Cup, like in the United States and stuff like that, which is going to be like it's usually the best place in the world to run these things because we have all these stadiums and stuff like that. Maybe they have like 12 stadiums, something like that, for all the teams. You know how many ways they can go around and visit all of them? A lot. Does that make sense? Both. That's correct. So the thing is, in this case, this is really just going to be 8 factorial, 40,320. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Because once I visited the first, like, whatever, 7 cities, there would only be one more to go to. Is that correct? At the end? Does that make sense, guys? All right. So the way to think about this formula a little bit, if I start saying like 8p, what was it? 5. The formula was saying it's going to be 8 factorial over 8 minus 5 factorial, which is 8 factorial divided by 3 factorial, right? Which is what? 8, 7, 6, 5, 4, 3, 2, 1. And this is 3, 2, 1. I'm just writing them all out because it's going to help me to understand one thing. So then this, if we have 8 slots here, 1, 2, 3, 4, 5, 6. Come on, bro. Why does he do this? Shut off Zoom? I'm using Zoom. I can't. All right. So we were over here. 1, 2, 3, 4, 5, 6. 1, 2, 3. That's 8. Does everybody see that? All right. Now, great. Now, if you're gonna only visit 5 cities, we know the answer was gonna be what? 8 times 7 times 6 times 5 times 4. And I'm saying there's something that you can sort of learn from doing this. All right, and it's gonna help us with the next part. Okay. So all I'm saying is if n factorial is the number of ways to arrange n things, right? Right? Then the total number of ways that you could arrange this stuff, if we had used all of them, is 8 factorial. We just saw that. Is that correct? But if you can't visit all of the cities, I can't arrange those anymore. Is that correct? Right? So then what happens is that what you could say is this number is like over counting stuff. Does that make sense? Right? Counting too much. Is that correct? So then what I could do is I could say, okay, well, every time you would have picked one of these things that you could actually do, like let's say I picked city A, city B, city D, C, city D, city E. Does that make sense? Now there would have been what? F, G, and H that I still could have picked. Is that correct? But then I didn't have to do F, G, and H in just that order. I could have gone F, H, G. I could have gone G, F, H. I could have gone G, H, F. I could have gone H, F, G. I could have gone H, G, F. Is that correct? Those are all the possibilities for those three cities. Is that right? Does that make sense? Yes or no? Some of you look like no. So then this is 6 ways. Is that correct? Is that right? No matter what you pick over here, there's going to be 6 ways to do that thing on the side over there. Does that make sense? You pick other 5 letters, whatever you pick, there's going to be 6 ways to rearrange the stuff on the other side. The 3 that I'm not picking. Does that make sense? Does that make sense? What's another way to say this? Well, I guess there's 3 times 2 times 1 ways to do this, or 3 factorial ways to do that. Is that right? So if there were 8 factorial ways to do all of it, well, each time that I was picking a right way, I was now doing 6 times as many as I actually need. Does that make sense? So we divide by 6, or you divide by 3 factorial. Does that make sense? Does that make sense? Because those are the things you can no longer order. Does that make sense, guys? All right. So now we have to do something non-distinguishable permutations. Or these are, ooh, that's not right. Or these are permutations of, come on, of objects that are not necessarily distinct. Okay? Or I was using the word distinguishable before. Distinguishable. Does that make sense? So before we were talking about arranging things and they were all different from each other. Is that correct? Now I'm going to talk about arranging things and some of them are not necessarily different from each other. Everybody understand what I'm saying? All right. So let's do an example first. Let's say we have A, B, C, D, A, B, C, 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 or excuse me, C, C, sorry. So we have these 4 letters now. Now actually, I'm going to type this. What's the matter? Yeah, you sit here and talk all day with this stuff. You would be surprised, like how it messes you up. Like my wife, she's a teacher, and she like the first week of school, she'll go to work, she'll come home all like raspy. Mucus cough? No, I got what this thing called COVID from before. And I had dirty COVID when it first came in. Like so like I go to this, I do all these math competition things or whatever. So I don't remember what year it was. I don't remember whenever COVID was like first started, right? Whatever year that was, okay? There was a case, if you go look it up, they found some guy with COVID or whatever in France 3-4 months before everybody said it was all going on. Okay. So then I remember April or March, something like that. One of those 2 months, that was when people started going like bananas and they were like, oh, we got to close everything and blah, 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 blah. Well, I remember in February, okay? Because I've never been this sick in my entire life, ever. Not even close. All right. Like I swear to God, I almost died. All right. I'll tell you. So my dad's a doctor. All right. So so I go to this stupid math competition. All right. And there's this guy at the math competition. He's the president of the organization. And I don't like him. So I sit there and I start messing with him all the time. Because I went to UF and he went to FSU. And he always wears FSU garbage. And I'm like, go Gators. So I just, oh, wait, I gotta, say something, right? So he comes in there and he's got to give the first meeting of the year to everybody. And he walks in this room and there's all these teachers and whatever. I don't want to be there. Okay. And it's a waste of my time and whatever. So we come in there and I don't realize he's even there. And I'm sitting there and I'm talking my nonsense. All right. And then he walks in and I'm all like ready to go. Right. So I get up and I yell at him and I go Gators and I, do this in his face. Okay. And he wasn't having it that day, I guess. He was sick. He was really sick, actually. Okay. So he turns around and he goes like this to me. Swear to God. All right. And I was like, bro, did you really just do that? Like, I could kill you right now. Like, I'm not going to go get sick for this, right? Like, this guy's like a skinny little runt. I mean, I'm not nothing anymore, but I'll kill this guy. All right. So I was like, all right, fine. Then we go to the next math competition because stupid things are every 2 weeks. So we're on the bus, and there's this kid hocking up a lung, like bad, bad. Okay. And he just came back from Wuhan, China, which happens to be the place where they claimed the disease was spreading pretty rapidly at the time. Does that make sense? Those are the only cases at the time, supposedly. All right. Literally from Wuhan. All right. The place. Okay. Now, I wasn't sick. I hadn't gotten sick yet. But the other teacher who I went with, he was sick on this trip, coughing and coughing and coughing and coughing. I'm like, dude, why you like, don't come? Like, what are you here for? You know what I mean? Coughing. All right, we go on this trip. There's like, I don't know, 45 kids or something like that, 50 kids, whatever it is. We come back, school. Probably about 20 not in school when we come back because they're all rooming in these rooms together. They all got sick. So I go home. I don't think I'm sick. A few days goes by. I start feeling not so great. I'm like, whatever. I don't really care. Like, I'm always sick. People get me sick all the time. It doesn't matter. Like, what's the big deal, right? And then I'm like, no, it was like, tired. Just like really tired. Okay. And like, I was like, this is weird. And then I was just like cold all the time, like all the time. And I was shaking a little bit. And then I would go and check my fever, and there was no fever. And then I don't really take medication at all. So I was like, I'm not taking anything until I have fever, right? So then I keep waiting and waiting. And then gradually, shit's getting worse. Okay. No, actually, no. So then I'm like, all right, what's this? What's going on? I never get a fever in the middle of the night. Like I'm cold as can be, like really cold. You know what I mean? I'm achy. I feel like I got the flu. All right. So I was like, I got the flu. Like whatever, it is what it is. Flu sucks. All you gotta do is rest. You'll be all right, right? I mean, as long as you take care of yourself. Flu actually is not that. Flu is really serious. Actually, flu one of the most dangerous diseases that actually exists in the entire world. That's what caused influenza. It killed like something like 9% of the entire population of the world. But the 1917. So the this so great. I got sick. It's getting worse. COVID's going around. Everybody's putting masks on all of a sudden. But bro, you don't have COVID. There's no COVID in the United States. You don't got COVID. Don't worry about it. There's no test yet. There's nothing. Okay. So then my dad, he's older, but he's a doctor. All of a sudden they call him and they're like, yeah, you got to come to the hospital right now. We need you. He hasn't worked in, I don't know, 8 years. And then in addition to that, they jab him up immediately in January before I got sick. Now, I was sick for a month. No longer than a month. I don't remember exactly how long, but it was over a month. All right. Every day, coughing, coughing, can't stop. Okay. The only way I could sleep was I used to cover my face like this. That was it. I could not sleep otherwise. I was just coughing. I couldn't stay in my room. I couldn't stay anywhere near anybody else. I just kept coughing, coughing, coughing. And then finally one day it stopped or whatever. But I was coughing up stuff every morning, like black and red things. My dad says I was coughing up my lung. I was wheezing. And supposedly, if you start wheezing, you're supposed to go to the hospital. I didn't do it. I don't know. But I didn't know that. You know, nobody told you at that time. You know what I'm saying? So yeah, wasn't so great. Anyway, ever since then, I can't stop coughing. Swear to God. No, it didn't make any difference because I had that Chinese kid later on who got me sick anyway. So well, whether it was him or the next Chinese kid or the next Chinese kid or the people they infected or the other people that got infected from God knows where else, you know what I mean? It didn't make any difference. Everybody got this stupid thing eventually. The thing was though, right at the beginning when you got that thing was bad. That thing was bad. Okay, like it got better after a while. Like you got it again later, it wasn't so bad, honestly. But at the beginning, no, my friend's dad died. You know, he died right at the same time. Like it was crazy. He died in like 4 days. Like it was nuts. You know, like it was pretty bad at the beginning. So anyway, um I'm just happy that I don't have like effects that I can tell are like bad. I mean, whatever, a cough could be worse. You know what I mean? Like some people sit there and tell you that they can't breathe properly ever again. You know, and then they're always tired from then on. You know, and then a couple of years later they die. You know, there's people die a year and a half later after having COVID. Now, also, a lot of people. So you're alive. You're alive, man. All right. So then all right, non-distinguishable permanent issues. So then if we have these letters and I start saying A, B, C, C, okay? So first, just to recall 4 factorial is the number of ways to arrange 4 distinct letters. What would be the difference in this case? Mm-mm. Should there be less, more, or the same if I arrange these letters? Why would you say less? Mm. Why? Why would that change anything though? What do you mean though? Be more specific. So why would there be less though? Yeah, but there's still 4 objects. I can still move around the 4 objects. Is that correct? Why does this make less? What can you not do with this right now? You can't switch those two and make another word. Does that make sense? But the C's cannot be rearranged. with each other to create another way. Does that make sense? Does that make sense? So it's like if I pick A, B, and then I pick like C1, C2. Beforehand, if I write 4 factorial, it's like saying that like you could switch these two. Does that make sense? Does that make sense? But you can't, right? Because of the same. Well, if you switch them, it's not going to give you a new way, right? So then this, there would have been 2 factorial ways you could order those two things. Is that correct? So what do? We take the 4 factorial and we just divide out the 2 factorial ways that we're overcounting. Does that make sense? Does that make sense? So we get 12. Does everybody see that? Students a lot of times will like this type of formula. Like there's 1A, there's 1B, and there's 2 C's. Does that make sense? So students sometimes like to write it this way. 4 factorial, 1 factorial, 1 factorial, 2 factorial. 1 factorial is really just 1 anyway. Does that make sense? But this is like based off how many times these things are repeating. So sometimes people also refer to this as repeated permutation. This is why I carry stupid shit around also. You don't know how many water bottles I've gone through since this also. I never even used to bring water bottles. Freezing cold water. Now, believe it or not, even like the markers on here, the dust from that used to mess me up bad when I first had COVID. Sorry? Nothing they can do anyway. You can't do shit. So that's called repeated permutation. Does that make sense? Any question? All right, so another example people usually do is they usually do this one. This is quite common. MISSISSI PPI. How many different letters can be constructed from the previous letters using each letter only once? How would you do this based off the previous one? That's true. You have M's, I's, S's, P's, right? How many total letters are there? 11. 11, whatever, right? There would be 11 factorial ways you could do the whole thing if they weren't repeating. Does that make sense? You gotta be careful. All right. Now, this is like S1, S2, S3, S4. Is that correct? But if I switch an S with an I, it still makes a new thing. Is that correct? But if I switch an S with an S, it doesn't do anything. Is that right? So these S's, no matter where I put them, there would be 4 factorial ways that I used to be able to arrange them that I can't anymore. Is that correct? Does that make sense? So how many? What? There's 1 M, there's 4 I's, there's 4 S's, and 2 P's. Is that correct? So then all you do is write 1 factorial, 4 factorial, 4 factorial, 2 factorial. Does that make sense? Because you can't arrange the P's, you can't rearrange the 2 P's with each other, right? There would be 2 factorial ways you could have used to be able to do that, right? You can't rearrange the s's anymore, no matter where you put those. There's 4 factorial ways you could do that. And then you can't rearrange these i's anymore with each other. There's 4 factorial ways you would have been able to do that. Does that make sense? All right, so this is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial, all over 4 factorial times 4 times 3 times 2 times 1 times 2 times 1. These guys cancel. 4 times 2 is 8. 3 times 2 is 6. This is 990 times 35. 35,000 minus 35, so it's 34,965. No. Minus 350. So this is 650, I'm sorry. But I was just doing my calculator. Does that make sense? What are you talking about? These? I'm just using definition of factorial. You gotta watch the beginning. Otherwise, it's not gonna be worth it. It'll be easy though, if you watch the beginning. You too. Okay? Trust me. Just 11 all the way down. That's all I'm writing. Oh. So then the pretty much. That's all it means, the explanation point. And all we're doing that for is because otherwise I'd have to write out so many numbers, right? Okay. All right, last one. Combinations. All right, now, first thing with this word is consistently used for permutations in common English. It's kind of bad. People use the word wrong all the time. Does that understand what I'm saying? But math has a specific definition. As math always has specific definitions. Does that make sense? All right, now this combinations, I don't know if you remember, but I said something and I really haven't talked about it very much. I talked about this order matters thing before, right? I mentioned it very briefly. Is that correct? Combinations, order does not matter. All right, what is combinations first? All right, so they write this NCR, okay? Sometimes people say N choose R. Sometimes people say that for this, like the C, all right? This is the number of groups taken R at a time from N distinguishable items. Or this is the number of groups of size R that can be taken from N different things. So the only difference here is arrangements versus groups. Does that make sense? In an arrangement, the order matters. In a group, the order within the group does not make a difference. That's what they're trying to distinguish. Does that make sense? Does that make sense? Give me an example. Since you said, what's the example? Say one more time. You put 5 people in a group, yeah? Yeah, that's it. You put 5 people in a group. Like if I say I'm gonna go first, and you're like, no, I'm gonna go first. I'm gonna be like, okay, go right ahead. What the hell is the difference? We're still both in the group. Does that make sense? Does that make sense? But if I say we're lining up, right? And I'm going first and you're going second, you're like, no, I'm going first. Well, maybe it could make a difference now. Does that make sense? Is that correct? Does that make sense? All right. So, first question. Compare NPR to NCR. Bigger, smaller, the same. What would you say? Oh, let's say, yeah. Let's say that. How would you compare these two things? Are there more arrangements or groups? Are they the same? Can you not tell? What would you say? How so? What do you mean? So you say if I say there's like 12 people and I choose 4 or something to line up, or I choose 4 of them to put in a group, you say there's gonna be the same number of ways I can line them up, the same number of groups I can pick? If there's 12 people and I pick 4 of them to line them up, or I pick 4 of them to put them in a group, you tell me it's gonna be the same number of ways? I don't think so. Otherwise, why would I even be talking about this? But in addition to that, that doesn't make any sense. NPR is bigger is correct. Why? How? Explain. Otherwise, you guys just guessing. Sorry, what? If we have 12 people and we're gonna pick 4 of those people, whichever ones we pick, right? And then I'm gonna make it. Well, let's ask this first. Let's say I have 4 people. How many arrangements will there be of these 4 people? And then how many groups of these 4 people will there be? There's one group. How many arrangements? 24. So there's 4 factorial ways to arrange this. Is that correct? But there's only one group here. Is that correct? They're still not the same though. There's 24 times as many ways in this case. Does that make sense? Yeah, there's 24 different arrangements. 4 times 3 times 2 times 1. You have 4 choices for the first one, then 3, then 2, then 1 for the letters you pick. Arrangement just means how many ways can I line up the letters? There's a lot of ways. Does that make sense? You know what I mean? So then but there's definitely only one group of these letters because whether I wrote this like this or not, still the same group. So then, but my point is there seems to be more permutations. Is that correct? Because you can arrange this stuff. No matter what you pick, you can move them around. Is that right? Does that make sense? Now, there are cases when the two things will give you the same number, but there's no way that there's going to be more of these. Does that understand what I'm saying? Does that make sense? All right, so that was that. All right, let's see what they write for the formula now. NCR. Does anybody know the formula? The only reason why I keep asking this stuff is because I know you guys have seen it before, these things. But I did this stuff in middle school. I'm not saying you did in middle school, but I know you did in high school at some point. Does that make sense? And usually what happens is that the teacher doesn't sit there and explain the stupid thing. They just tell you the formula. People just plug numbers in the formula. That's all they do when they take the test, and nobody knows what it means. And then everybody forgets it. Does that make sense? So when I say you did it before, it doesn't mean they taught it to you. Okay. I really shouldn't call that someone did it before. Anyway, formula. All right. N factorial divided by, well, actually, I'm going to write this differently. First thing they say is this. And they write that. That's the formula. All right. Now, if you notice, this portion here is the NPR formula. All right. So somehow, all we need to understand here is why we can take NPR and just divide by R factorial and get the answer. All right. All right. Let's try and do it with an example. Do you understand? Okery dokery. All right, let's say, let's have our 5 letters, whatever. And everybody understands why I'm picking letters. It doesn't matter what you're talking about as long as they're distinguishable. Does that make sense? All right, so I'm just saying there's 5 things, whatever they are, 5 different things. All right, so 5 letters. How many 3-letter arrangements can be constructed? And then how many 3-letter groups can be selected of those letters? So you can think of it as 5 different people. You wanted to line up those people for the first one. And then you could think of this as 5 people and you're picking 3-person groups. Does that make sense? Another question sometimes people ask, but the same thing is, how many presidents, how many ways can the 5 people be given positions? President, vice president, and treasurer. So these 2 questions are sort of like the exact same thing. And then this question, how many ways can 3 senators be selected from the 5 people? And then these two questions are like the same question. How do I do the first one? I don't care. This is why I tell people not to use the formula. Because if you use these stupid formulas and you don't know what they mean, then what's going to happen is that you're not going to be able to check your work and you're not going to be able to see if you're doing it right or wrong. Does that make sense? That's really the only problem with it. Does that make sense? There's no problem with the formula. The formula's perfect. Otherwise, we wouldn't call it a formula. Does that make sense? The question is, what does it mean? So I know when to apply. Go ahead, sorry. 3 slots. That's correct, sir. Very good. All right. So then if you have A, B, C, D, E, right? And we're trying to make a 3-letter arrangement, we have 3 slots, right? Something has to be put in the first one, something has to be put in the second one, something has to be, so we can make a 3-letter word. Is that correct? How many choices do I have for the first letter? Well, if I have 5 letters, I have 5 choices. Does that make sense? Now, when I say a 3-letter arrangement of these things, you would assume that you're not going to pick the same letter twice necessarily. Does that make sense? All right. So then this would be 4. Then there would only be able to be select for the next one, no matter what. I pick something for the first one, right? Then I pick something for the next 2, and then there would only be 3 left over. So therefore, it would have to be what? 60 ways. Is that correct? Does that make sense? But you're right. Does that make sense? All right. Now you're close. But it's 5 factorial divided by 2 factorial. Does that make sense? Because the formula is n factorial over n minus r factorial. But again, this, like, it's not worth it for this. Does that make sense what I'm saying? Because I'm telling you, you're going to forget the formula. You won't forget that, though. Does that make sense? If you keep doing it that way. Does that make sense? What do you mean? I just said it was n factorial divided by 2 factorial. It's 5 factorial divided by 2 factorial. Now, for the other type, though, I recommend using the formula. All right? But let's just, well, sort of. But let's just first I just want to even explain what I even mean first. Does that make sense? All right. So this was the same as before. Is that correct? This one's different now. This is definitely the other stuff. This is, I wrote groups here. Is that correct? Now with the formula in the first case was 5p3, which is 5 factorial over 5 minus 3 is 2 factorial. Does that make sense? Does that make sense? So this is 5 times 4 times 3 times 2 factorial over 2 factorial, and then we get the same answer. Does everybody see that? Question here, anybody? All right, now it should be, yeah. For this one, for the next one. This is the previous formula, right? I haven't done the new one yet. All right. Okay, so then, any question with this so far? Other question? All right, so now we're still selecting 3 things. Is that correct? Right? And this is going to make sense because I'm going to start writing out all the cases. I'm going to start writing out everything so you can see exactly what I'm counting. Does that make sense? And why it's giving you these values and stuff like that. All right. But why don't we just try and write them all out before we start? Okay. Because there's not going to be that many ways we can do this. Does that make sense? All right. So A, B, C, D, E. Now I want to write out groups of stuff. Does that make sense? So then I could do what? A, B, C. I could do A, B, D. I could do A, B, E. Is that right? But now I can't do anything else with A and B. Is that correct? Is that right? So I move it around. So then I could do A and C, I guess. I could do A and C and D. I could do A and C and E. Now I'm screwed with this. Is that correct? Then I can do what? A and D and E. And that's it with the A. Is that right? Then we could start doing things with B, I guess. So I could have B, C, D. I could have B, C, E. Is that right? And then I can't do B and C anymore. So then I have to do B and D, but then I'd be forced to do E, and now I can't do B anymore. Does that make sense? Does that make sense? Then what would be the next one I have to pick? C, what else? I'd be forced to pick D and E now. Is that correct? There's nothing else I could pick. Is that right? So then how many ways are there here? What is this? 6, 9, 10? That's not that many. Is that correct? I'm not saying you should do it this way because you're not going to write them out always right. Does that make sense? The formula is actually easier, believe it or not. All right. Because I'll show you, like I'll try and write them out sometimes and I can't write them all. Like I'll always apply one. Does that make sense? All right. So then but I can count the stupid thing and tell you the number without a problem using the formulas. Does that make sense? All right. So then, and usually the number is more important. Okay. So if I'm correct with this and we did this right, we should be getting 10. Is that right? Let's see. All right. So in this case, N is still 5, R is still 3. Is that right? So now it's 5C3. Formula says that what you do is still write the same thing here, still do this minus this and write this here. Does that make sense? The only thing you do is take this thing and write this also there. Does that make sense? Okay. Does that make sense? All right. Every time you do this, there's going to be something on the bottom that's going to cancel. Is that right? Does that make sense? Just cancel that, cancel this, and you get 10. Will be better. Otherwise, there's a problem. Does that make sense? One of these places, right? Okay. Now, great. The formula worked, we think. Why, though? Does that make sense? All right. So we had previously 5 factorial over 2 factorial. Is that right? And we got 60 ways, right? Right? And now we wrote out all of the cases here for the groups. Is that correct? Right? But wait a second. We should be able to figure this out now. We should be able to relate these two things together. Does that make sense? There's 60 arrangements. There's 10 groups. And I said everything about this stuff is always with multiplication. Is that correct? There's 6 times as many right now. Is that correct? 60 divided by 10. Right? 6 is the same thing as 3 factorial. Is that correct? Why? Anybody tell me? That's correct. But why? What does that have to do with this? Why? What is? Yeah, you weren't here for the beginning for this part, so it might be hard. But what is this? What does this number factorial thing have to do with this? Like, what does it do with these things? Why would I need to multiply this by 6 to get the other one? So if I have a group of these things, why would I have to multiply by 6 to figure out the number of arrangements? Because that's how many arrangements there are. If you have this, right? How many ways would there be to arrange that? Well, you could do what? ABC, you could do ACB, you could do BAC, you could do BCA, you could do CAB, you could do CBA. There's 6. Is that correct? Because you have three choices for the first one, then 2 choices, then 1. Is that correct? Does that make sense? How many would there be for this one? 6. Is that correct? How many would there be for this one? 6, 6, 6, 6, 6, 6, all these things. Does that make sense? Does that make sense? There's 3 factorial ways to arrange one of these individual things. Is that right? But we can't do that anymore. Does that make sense? Does that make sense? So if the previous answer was 5 factorial over 2 factorial, right? And that was giving us 60, right? Well, then we need to take this thing and divide by 3 factorial. Does that make sense? You can no longer arrange within the group anymore. Is that correct? There are many things inside the group. That's why they're dividing by the r factorial. So this is n factorial over n minus r factorial times r factorial. They're dividing by an additional r factorial now. Does that make sense? Because you can no longer arrange within the group. Do you understand, guys? That's pretty much it. All right, what is this thing? Evaluate this, 10p2. Now, this is where I start laughing sometimes. Because if you do this by using the slots and the idea of the way I explained it to you, you can do it in your head in like a second. If you do it by writing it out with the other stuff, then sometimes people make a little bit of mistakes. What'd you say? 90. How do you get 90? That's correct. This is very good also. There's 10 things here. This is the way you explained it. Very good. So there's 10 things here, okay? And we want to arrange 2 of them in a line. Does that make sense? Now, you can use the formula. There's no problem. I'm just trying to make sure you understand what it means also. Does that understand what I'm saying? So this is 10 over this minus this is 8. So we get 90. But if you remember in terms of slots, this is the number of ways that you can arrange 2 items out of 10. All right, so there's 2 slots. First one's 10, second one's 9. So we get 90. Does that make sense? So this next one means what? The number of ways that you can pick groups of 4 from 9. Is that correct? What you say? You guys want to try it? What'd you say? 114. Now I gotta think. 5 is 9 times 8 times 7 times 6. 42 times 72 over 24. 3. 42. What did you say? 112? Wait. 9876 over. I think it's 42. I think it's 42 times 3. Close. Yeah, but then you got to divide that by something. I want you to try and do it. Use the formula. Yeah, but you got to count there. No. One 126 is correct. 9C4 is the same thing as, so don't forget the formula. It's NCR equals to n factorial all over n minus r factorial divided by r factorial. But I don't know why you guys didn't believe me when I said it was 42 times 3. 42 times 3, right? 40 times 3 is 120. 2 times 3 is 6. You get 126. So then this 9C4, this is 9 factorial over. Then we have to subtract. We get 5 factorial. Then we take this thing and we write it over here. Is that correct? Now, again, the reason why anybody's having a problem with this is you're not writing it out. Does everybody understand what I'm saying? 9p4. But then you should be getting the number he was saying before. That big number. So then this is 9 times 8 times 7 times 6 times 5 factorial. 5 factorial. 4, 3, 2, 1. These cancel. Is that correct? Then 4 times 2 is 8. Is that right? 3 goes into 6 twice. Does everybody see that? 9 times 7 is 63. Times 2 is what? 2 times this is 126. Does that make sense? All right. Sometimes people like to, I mean, when I was a kid, like they used to explain it like this also. Like they would say, like, there's 9, there's a 4. So you just do 9, 8, 7, 6, and then 4, 3, 2, 1. Does that make sense? It's the same thing though. Okay. Yeah. Well, that's what I just wrote right here. I just canceled the 5 factorial. Does that make sense? But it's like a faster way, sort of. It takes only a second to write the other thing. It's not necessarily worth it. Does that make sense? All right, there are 13 members on a board of directors. If they must form a subcommittee of 3 members, how many different subcommittees are possible? So now the question you need to ask yourself when you're doing these things is, first question should be what? What's the first question you got to ask? Is it permutation or is it combination? Does that make sense? Because you're going to be able to do one of them to answer all the questions. Does that make sense? So is permutation or combination? Do you remember what I said to try and tell how to tell the difference? I said something was like the most important thing. Do you remember what I was talking about? I wrote on here while we were doing this. Yeah, this part. If it's a group or an arrangement, is correct, right? So but that's, you're right. So these two things are the things that tell you. Does that make sense? Does that make sense, guys? So you got to ask yourself, in the are many things that you're doing something with, does it matter if you can switch them and make a new way? Or if you switch them, is it just like a group and it doesn't really make any difference? Does that make sense? Does that make sense? So what about this one? What would you say? So in other words, you should be asking yourself each time, does the order matter or does the order not matter? If the order matters, it's an arrangement. It's a permutation. If the order doesn't matter, it's a group. It's a combination. Does that make sense? In this case, the order doesn't matter is correct. So that means you use the choose formula. Does that make sense? So then this would mean what? 13C3. Does that make sense? So that's 13 times 12 times 11 all over 3 times 2 times 1. So this is 6 is 2 is 143 is 286. So, all right. Does that make sense? By the way, one other thing. You can do all of this on your calculator because you have a calculator that supposedly you are supposed to purchase. I have to say, I've never done it on the calculator, like myself. Okay? Just because they never taught it to me when I was a kid this way, and I don't understand it. But once you get it, it's really easy to do it on a calculator. Okay? As long as you understand what it means, it's perfectly fine if you want to do it on the calculator. All right? Now, this all comes from this button here. This is the only time in this entire class we're going to use this math button, but we're going to use this math button. Does everybody see that? All right, so if I go to the regular screen, this is where you usually just calculate stuff. All right. Then, I don't know, what was it? 13C3, right? So 13, I type 13 first. I go to math. Does everybody see that? Then I go to prob for probability. Then you see it says NPR, NCR. And then there's factorial also. Does that make sense? So you just go down here, click NCR. Does everybody see that? Push 3. Does that make sense? Bada bing. that make sense? Don't forget also, I have posted videos for all of this online for how to do all of these things. Okay. So if you ever click on the D2L, it says topics and video links on there. If you click on there, you do not have to memorize any of these things. I would recommend just watching the video again and seeing somebody doing an example. Does that make sense? All right. And they're labeled. They say like TI 84 calculator video and stuff. Does that make sense? All right. Mm-hmm. This is the thing I was showing you guys last week. All right. So all you do is click on the videos on in D12. But there's a link. It says topics and videos link. All right. I'll show you at the end if anybody reminds me. All right. Say again. There's no TI-85. Yeah. I don't know why they like. These TI calculators, I gotta say, I hate telling people to purchase TI-84 because the calculator was old when I went to school. In the 90s, this calculator was old. So then I was like, they came out with a calculator called TI-89 at that time. And I remember they gave it to us when I was in the school, and they're like, because you need it for the math competition. We go to the math competition. I remember that that was the last time anybody was allowed to use a calculator at the math competition because they only had 15 trophies. And I remember 21 people got a perfect score, first place, ran out of trophies, state competition, 2,300 people, I remember. Anyway, so like no, but it's because people had a damn calculator. You just didn't even know how to do anything. Like there's a symbol in there. You just click it, answer. Thank you. Now with this, it doesn't really work so well, honestly. It's a little too much. You have to know what to type. Does that make sense? But like you want to do algebra or something, it does the whole thing for you. Like you don't even know how to do anything. All right, if you know what to type. Okay, which is important because you're supposed to learn how to do these things because they're supposed to be tools. Does that make sense? The only problem is it's hard to understand what it means and learn the calculator at the same time. Usually, it's more important to learn what it means. The calculator is usually a joke to learn how to use. Does that make sense? You can usually learn it very quickly. All right, when you need to. But anyway, they have these calculators with this thing called CAS, Computer Algebra System. All right, that means I can type the problem into the calculator and it'll do it for me. Does that make sense? Solve things in terms of variables. All right. This TI-84 doesn't do that. But every calculator since 1999 does. So that's why I don't like telling people to purchase this really. But this is the only one you can get from the Academic Success Center. Does that make sense? All right. How many 4 different numbers can be formed using the digits if repetition of digits is not allowed? This would be 7p4. Or this is 7 times 6 times 5 times 4. That's 42, 80, 400 or something. Is that right? $840. An author has 6 different books in print. If those 6 books are to be stacked in a random order, what is the probability that they are arranged in alphabetical order from top to bottom? How about 7 books? The first one would be 1 over 6 factorial. Second one is 1 over 7 factorial. There's one way to put things in alphabetical order. Is that correct? Does that make sense? So there's one favorable way. What the question really wants you to say is, how many total ways are there? Does that make sense? So if you have books like A, B, C, D, E, and F, right? There would be 6 factorial ways I could order them. Is that correct? So it's 1 out of 6 factorial for the first one, and then it's 1 out of 7 factorial for the second one. Does that make sense? Joel, question? So like you got these books, right? I'm just saying, let's pretend the name of the book is like the first one starts with an A, the second one starts with a B, the third one starts with a C. Does that make sense? Then there's going to be one way to put them in alphabetical order. Is that correct? So what's the probability that I'm going to put them in alphabetical order? Well, it's the number of ways that I could make them in alphabetical order divided by the total number of ways you could do anything. Does that make sense? So then it's 1 And then divided by what? Well, I guess there would be 6 factorial ways that you could have ordered them if you weren't really paying attention. Does that make sense? What I'm saying? Does that make sense? Question with this? And then if they change it to 7 books, now it'd be 1/7 factorial. Does that make sense? Refer to the table which summarizes the results of testing for this thing. A test subject is randomly selected for the disease. What is the probability the subject does not have the disease given their test result is positive? What is the probability the subject does not have the disease given the test result is positive? What would you say here? This next one, we'll do the next one also. I'm going to do it, and then we'll do some more examples for the next one on Tuesday. Does that make sense? You do have a test and a quiz though that's due by Thursday of next week, I think. All right. Thursday. Sorry. When I was in New York, these people that's always say it all the time. Thursday. What's the answer to this one? How do we do it? Four? What are you talking about? Yeah, how do we? Yeah. So I want to find the probability that the subject does not have disease, given the fact that the test result was positive. Go ahead. So 22 divided by what? 103? Yeah, you're right. 22 divided by 81 plus 22 is correct. They said positive, so that's the reduced sample space. Is that correct? Then they said doesn't have the disease, so those are the 22 people. Is that right? So it's like about 22%. It's a little bit less than 22%. Does that make sense? 21 point whatever. Question? At least I think. All right. 2.1% of a population are infected with a certain disease. There is a test for that disease. However, the test is now okay. This question that we're doing right now, this one's a little bit more. Yeah. All right. This is something that's referred to as Bayes' theorem. I feel like though that like this summarizes everything we have to know. Does that understand what I'm saying? Once you know how to do this one thing, it's gonna go over and or and all of this stuff together. Does that make sense? And conditional, all right? So that's why I think it's important. Does that understand? Well, actually, excuse me. It's important in general anyway, this idea. All right. But there's two types of statistics. Sometimes people call like frequentist statistics and then Bayesian statistics. So there's like two types, sort of, even though they overlap in some cases. And then some things can be neither classified as either one of them. But the there's a whole field called Bayesian statistics. Does that make sense? All right. So so this guy Bayes, whoever this guy Bayes is. All right, this came from like an older version of your book or whatever. Oh shoot. Sorry, 1 second. For some reason it didn't copy all the pages. Sorry, it got printed slightly out of order. So this is like the first part's on the right. Okay. Um. Anyway, so he says Bayes theorem. To me, Bayes theorem is literally just um the same formula we talked about before, conditional probability. All right. It's just an application of some idea associated with conditional probability. But you know, sometimes it gets confusing to do some of the questions. All right, this came from your book and stuff. Guy starts explaining this thing. He starts talking about prior probability, posterior probability. Prior means some probability you know before doing something, and then posterior means some additional information was provided to you about something, whatever it was, and you changed or could had the opportunity to change what you thought the probability was going to be. Does that make sense? All right. So the example he's going to discuss is about cigar smoking and males and females and stuff like that. All right. So I remember I went to this wedding once, and there was a cigar room in this wedding. And I go in the cigar room in the wedding, and I've not smoked cigars. Like this room was completely there's just cloudy everywhere. These people are drinking in there and stuff like that. And like honestly, most people walk in, they're like, I can't stay in here. Like you just can't stay in there. It's just like that. It's that thick. All right. So then since people start going outside, they're smoking cigars outside because it's actually that bad inside. Like they like the cigars, but they're smoking outside. Most of the people who are doing this are men. All right. There's some women though, definitely, but most of them are men. Okay. I still remember this to this day though, because we were trying like they were like my cousin's wedding, and they were like we gotta have shots. They wanted to have shots. So then I remember we go to the bar, and they're like, oh, they close the bar. There's no more shots. I was like, okay. And they're like, the cigar room's opening up. So we go in there, and then it's all cloudy or whatever. There's a bar, and they're like, oh, you can go to the bar. I was like, okay, so I'll get you guys shots now. So I was like, give me 17 shots, right? And then the guy's like, because it was free, right? So then I was like, give me 17 shots. They want them over here. Tell me when you're done. He's like, no, we don't have shot. We don't do shots in here. This is a cigar room. We don't do that. I was like, okay. What do you do? He's like, I have cognac. I was like, okay, I guess. So then they go and they start. I was like, well, I guess pour 17 cups of cognac. You know what I mean? Right. And then so he pours the thing. This guy's standing there next to me. I don't know who the hell this guy is. All right. And he's like, why don't you? He's like, cheers. Right. And we were all sitting there and saying we were going to take a shot. So I take the cognac as a shot. You're not supposed to do that. Anyway, I really got drunk very fast from this. Anyway, I'm just saying, don't ever do it. But the reason why I'm telling this dumb story is because of the fact that like there really were a lot more men in them. All right, a lot more. Okay, and so this guy says the Gallup organization randomly selects an adult American for credit card survey about our card usage. Use subjective probabilities about the following. What is the probability that the selected subject is a male? What would you say? 50%. All right. This is referred to as a prior probability. Does that make sense? All right. After selecting a subject, it is later learned that the person was smoking a cigar during the interview. What is the probability that the selected subject is a male now? Is it still 50%? Why would you say no? Okay. So what would you say then? Yeah, we're just guessing. Sure. Well, you think it's higher, right? Ends up being about 85%. Ends up being about 85%. okay, with these numbers that these people use. Which of the two is a prior, which is a posterior? All right, this is called prior. This is called posterior because we have updated our probability given this new information. Does that make sense? Question? All right, now I'm going to show you why I find this author to be an asshole. A few reasons. So first, instead of explaining anything about this formula, they just write the formula. And I feel like most people get extremely confused by this. And I'm going to explain it with one more line, and I think you're going to tell me at that point that it's easy. Okay? But he doesn't write it. So I think he's an asshole. But then I know I'm right because of what he writes in this question. So in Orange County, 51% of the adults are males. It doesn't take too much advanced mathematics to deduce the other 49% are females. Okay, so like this is the asshole part. First of all, you don't even need to write this, right? Okay, and then you could have just said it's 49%, right? No, you're an idiot because you couldn't figure it out. All right, anyway, but this is nice guy. All right, so one adult is randomly selected. I can't believe they let that in the book. You know what I mean? So like one adult is randomly selected for a survey involving credit card usage. Find the prior probability that the selected subject is a male. All right, well, they told us 51% here, so I'm going to go with 51%. Does everybody see that? All right. It is later learned that the selected survey subject was smoking a cigar. Also, 9.5% of males smoke cigars, whereas 1.7% of females smoke cigars, based on data from this thing. Use this additional information to find the probability that the selected subject is a male. So now they're asking you to calculate, right? Given the fact that you know the rates at with which women and men smoke cigars. Does that make sense? All right, this number here means 9.5% of males. So this is the chances that you're going to smoke a cigar given you're a male. Does that make sense? Now, according to this thing, it's saying either you're a female or a male. It's not classifying other types, okay? So the thing here is that this, we're either, I don't even like them saying females in this case. All this really should mean is not males. Does that make sense? All right. So 1.7% here. This is the probability that this person was smoking a cigar given the fact that they weren't a male. Does that make sense? Whatever. Does that make sense? All right. These numbers here at the top here, the chances that you are male was this. The chances that you are not male was that. Does that make sense? Again, hopefully this reviews a few of these things. Okay? Does that make sense? Compliment. Is that right? Okie dokie. What do they want now? Use this additional information to find the probability the selected subject is a male. But he says use the additional information. So what this is saying actually is find the chances this person is a male given what? What's the additional information? That they're smoking cigars somehow during this interview. Is that correct? Because that's normal. So it's crazy. So like all right. Does that make sense? All right, that's what they want. Does everybody see that? Now we don't have that. We have this. We have that's 9.5%. Does everybody see that? I'm gonna write out a couple pictures, okay? I'm gonna do a Venn diagram. There's people that smoke cigars. There's males. There's males that also smoke cigars. Does that make sense? And then there's people that are neither male nor cigar smokers outside here. Does that make sense? Now this says, what's the chances you're a male given the fact that you're a cigar smoker? Does everybody see that? Well, using the definition that we said, this is the probability of people that are males and cigar smokers divided by the number of cigar smokers. Does that make sense? Because this is conditioned on the fact that you're a cigar smoker. So then really, I only care about that part. Is that correct? Well, if you say, given you're a woman, I only care about the women. Is that right? All right. All right. I'm going to rename these regions a little bit. I'm going to call this region here 1, and I'm going to call this region 2, because that's the only part we care about anymore. Is that correct? Well, this top part is really just region 2. Is that right? The bottom part is really just regions 1 or 2. Is that correct? Does that make sense? All right, region 2 is the same thing as saying M and C, right? Region 1 is the same thing as saying not a male and it's a cigar smoker. Does that make sense? Region 2 is completely disjoint from region 1. So if I'm saying or here, all I have to do is add the two things. Does that make sense? Total number of cigar smokers are the cigar smokers that are men and the cigar smokers that are not men. Is that correct? Is that right? So then this plus the chances that you're going to be a male and you're a cigar smoker. Does that make sense? All right. Now, this is the part that the guy writes in the book. So he skipped writing this and he skipped writing this. Does that make sense? All right. Now he says, all right, well, what's the chances that you're, well, male and cigar smoker? Really, that's like 2 slots. You got to be male, then you got to be a cigar smoker. Is that correct? So then the chances you're a male times the chances you're a cigar smoker, given the fact you're a male. Denominator is going to be the chances you're not a male times the probability you're a cigar smoker, given the fact you're not a male, plus the probability you're a male times the probability you're a cigar smoker, given you're a male. Does that make sense? That's the formula. All I'm doing is just writing these things out now. Does that make sense? All right. I don't really do it this way, though. I draw a picture. You can either be a male or you could not be a male. The chances you go down the male road is 51%. The chances you go down the not male road is 49%. Does that make sense? If you go down the male road, you could smoke cigars or you could not smoke cigars. Is that correct? Given the fact you're a man and you went down the cigar road, you would smoke cigars 9.5% of the time. Is that correct? If you're not a male, you can either smoke cigars or not smoke cigars. The people that smoke cigars, this is 1.7% of the time now. Does that make sense? How often would I go down this side then? And how often would I go down this side? If it's 9.5% of the time that I'm going this way, then it's going to have to be 90.5% of the time I'm going the other way. They have to be complements. Does that make sense? Does that make sense? Given you're a male, you smoke cigars 9.5% of the time. Given you're a male, the amount you don't smoke cigars would have to be 90.5%. Is that correct? So then this is going to be what? 0.9, whatever, 83 here. Is that right? Does that make sense? All right, this stuff looks crazy, but it's really not. All right, so then if I went down this road right here, it's M and C. This is M and not C. This is not M and C. This is not M and not C. Is that correct? Does that make sense? All right, so then here, this diagram is just trying to help you understand like what all this means a little bit. All right, so the top part says M and C, right? 51% of the time I'm male, 9.5% of those times I smoke cigars. Is that correct? 51% of the time I'm male, 9.5% of that I smoke cigars. Is that correct? 51.095. Then this is the exact same thing. Does that make sense? Does that make sense? What do I write here for this part? Not male and C. but times 49%, because 49% of the time you're not a male. Does that make sense? And then this will give you the number, whatever they want, 0.85, something like that. Okay. Now, I'm going to draw one more picture, and then we're done. I'm sorry this is taking so long. If I have men here and not men there, okay? Let's say this is 51%. Let's say this is 49%. Does everybody see that? Then 9.5% of the time, or like 1/10 of these men, they smoke cigars. These are cigar people here. Does everybody see that? Does that make sense? Then out of the women, like less, 1.7%, those are cigar people. Does that make sense? Now we ask, what's the chances that you're going to be a male given you're a cigar smoker? Is that correct? Cigar smokers are these people. Does everybody see that? What's the chances you're going to be male? This part. Is that right? So 85%. Does everybody see that? All right, that's all. We'll do another example of this next time. Okay.